Hello, in this video I want to tell you about SQL syntax. And here we can see most common data types in SQL. It's decimal, that used to store numbers with a fixed number of digits before and after decimal point, big integer, big serial for auto-incrementing integers, boolean for true-false, data for date, integer for integers, and money and text respectively for those data types. Here we see table client with columns ID, auto-incrementing age, first name, last name, email, the email has constraint unique, and gender, birth date, and also age constraint older than 10 years old. So let's create database store and connect to our database. Here we created table client and we see our new table and inserted data for client table. And here we see our clients. Let's also create table orders with ID, big serial, order, price, quantity, date, and foreign key for our client table with reference to client ID. Here is diagram between these two tables. And let's create our table order and insert sample orders. Here is our orders. And let's clean the screen. And let's start from sorting data. Here we use close order and we can sort our data in ascending or descending order. And let's sort our orders by price from higher to lower price, from 22 to 0. Also we can use offset keyword so as to omit first entries from our result set. For example, in this case 5 entries. And if we insert this request, we will have orders that are missing first 5 entries. So first 5 entries are omitted. This keyword like helps us to find matching words. For example, with this pattern %.com we can find our emails ending with .com. So we found clients with emails ending with .com. And this pattern helps us to find words with exact number of characters. So it will start with S and have 3 more characters. And we found Sika for this match. It has exact number of characters, S and 3 more characters. Finally, we can use I like that ignores case, and we can write any word surrounded by these symbols and find, for example, this email that is surrounded by .com and this first part. If we write this request and join our clients with orders, we can see that we have duplicates in our database. So we have a number of clients with the same name and the same orders. For example, milk. There are 3 milk orders. And for example, let's start by counting our duplicates. Here we select orders and count them, which also grouped as aggregate function using having, and we have our milk that appears 3 times. And here is also our milk that is repeated. So, supposing we need to delete our duplicates from orders, and in this request we delete entries from orders table that are not unique. So we write not before our subquery. So here we got our unique orders. All orders are unique. And let's here select our duplicated orders, and we see two orders with milk, and if we select all our orders, here we can see also our duplicates. So using this request we deleted our orders that are not unique, and we have only one milk order. And supposing we also need to delete clients that do not have orders, and we use this subquery to delete clients from this subquery where client has no order, and we deleted 5 clients. So we have clients that match IDs from orders. So here are our IDs from clients table, and they match IDs from orders table. 1, 2, 3, 4, 8, and here. So here is aggregate functions, and for example we can multiply our order prices by quantity using sum. This will get average age from our client, average function, it's 35 years. Here we can get maximum price of order, minimum age for client, and also we have constraint for client with age more than 10, older than 10. And finally we can count our clients by gender, male and female, and we got 2 male and 3 female clients. Union is a set operator in SQL that we use to combine 2 or more queries. There is union and union all, and union used for unique results set, and union all includes duplicates. So here using this query we can get male and female clients together. So here is our male client and female united. When having clauses are using to specify the request, and having clause is used with aggregate functions. We are not able to use var with aggregate functions. Clause must not contain aggregate function. And here we got clients with age more than 25. And here are our clients with the age more than 25. And here we use having to get the age group with average age older than 30 years. Coalesce is used to return the first non-null value from the expression. In this example you can see that we use email as a first parameter and NA as a second. And if there is missing email we will receive NA. So Justinian and Connor do not have emails, so we have output of NA. That's how coalesce works. Date keyword is used to work with dates, and in this example we can select orders with date more than 21st of January 2023. And here is our orders after this date. And using this request interval 3 months, we can get orders within the last 3 months. This is beer and cheese. Here we extract our 3 months interval. And we can also extract year from date. And here we got years. And this is also a number of queries that we can use date. For example, we can extract year, we can extract day of week, and we can even extract a century. So we extracted 21st century, first day of week, year 2023. Age function is designed to calculate age, and it takes date of birth, for example, as a parameter. And in such way we can calculate the age of clients from our table client. Thus we can see that Justinian is 20 years old, another Justinian is 43, and Connor is 80 years old. Check constraints are used to filter and check data before insertion in table, and here we can see check constraint of age, check constraint for gender. We can insert only female and male values. So if we add such constraint to our table client and try to insert data with the gender NA, we will receive an error that violates check constraint, gender constraint. OnConflict provides us with two options, do update and do nothing. On the one hand, do update updates information with existing client in database. For example, we already have Justinian with the same email, and we update the age of the existing Justinian because we have unique constraint for email. Here is our Justinian with the same email and age 10. And if we insert our query, we update the age of existing Justinian, and we will have age 30 because existing Justinian has the same email. And let's check. Here you can see the age in our database and the age we write in our query. And we received updated Justinian with the age of 30. Do nothing, on other hand, does not update information in database, it simply emit error. So in case of conflict, we just not update our existing data, so we have zero insertion, and Justinian has not been updated in table client. Subqueries are designed to add additional query in our main query. For example, we can see that we select average price in our subquery, and in the main query we select prices that are more than our average price. And if we select average price, we can see that our prices are more than this 7.9. Indexes are used to improve query performance, and in this example we create an index for client ID column of table orders, and this index will store a copy of the client ID column in a separate data structure, and this can improve the performance of our queries for this column client ID. So we just created a new index, and let's select clients with ID more than 1, and we see that it works quickly, and we can select clients with ID more than 3 and everything goes well. We use virtual tables that simplify our queries. In this example we select top clients, and we select top clients by the total amount of their orders. In this way we multiply our prices by quantity, and we also join our clients with orders and limit and sort our result set. Finally, we can select everything from the view top clients, and we will receive our top clients, top 10 clients. So we just created view and we got our top clients. Stored procedures are functions that we use to return specific data. In this example, we use function getClientOrders, and we return orders of specific clients, and we use client ID as a parameter. In this first part, we return the design of our table that we want to return, and the second part we write a query so as to return orders of the client of ID we just inserted as a parameter to our function. So we just created this function, and let's select orders of the client with ID 1 and orders of the client with ID 2. SQL transaction is a grouping of one or more SQL statements. A transaction can commit a single local unit or rollback to become undone. In SQL, transactions are essential for maintaining database integrity. And here we see the example of transaction that starts with begin and ends with commit. Transactions have properties of atomicity, consistency, isolation, and durability. And here we inserted our values in table client and respective orders. And here we used current value of client ID sequence. This shows our last ID of client IDs, it's the last client. And also we have sequence for orders. Let's select sequence from orders. And here we can create our own sequence, for example, product ID that starts from 1 and increments by 2. Let's create new table product with ID. That would be our sequence and name, and insert a couple of values. And we see that each ID is increased by increment that we indicated it was 2, 1, 3 and 5. And here we can see our sequence. Also, we can select next value of our sequence, and let's check how it works. And we got next values for our sequence, also increased by 2. Transactions rollback is used to prevent commit of that transaction. So instead of commit, we simply put rollback, and for example, our insertion in orders table will not be committed if we add our rollback keyword. So we did not insert our data. Window functions allow performing complex calculations over a subset of rows. Input values for window functions are taken from a window set of a select statement. Window functions use over clause. In this example, the rank function is used with the over clause to calculate the rank of each client based on their total spend. And for the total spend, we multiply the price of an order by its quantity and order the result in descending order. And here we receive the rank of clients by orders. A common table expression, also known as CTE, is a temporary named result set that can be referenced in SQL statement. A CTE is similar to a subquery, but it provides several advantages, for example, making the SQL code more readable and maintainable. Particularly in this example, we created common table expression average age by selecting average age from the client's table, and we can reference this common table expression by select statement. So we just created common table expression and got average age for all clients. Full text search allows to search for words or phrases within a block of text. It helps to perform advanced searches or rank search result based on relevance. For example, this SQL query that selects data from table client performs a full text search on the first name and last name columns for the terms John and Doe, concatenated with an ampersand operator. This is the full text search condition that filters rows returned by the query. The tsVector function creates a tsVector from the concatenated first name and last name columns, which is then compared to a tsQuery created from the search terms using ampersand operator. The ampersand operator specifies that both terms must be present in the search results. So let's post our request, and here we search for John and Doe in two columns, first name and last name. Let's consider another less complex example, and here we see table of client, and let's create index for name column of client table. And let's search for John in the first column name, and we got such result set. A case expression is used to perform conditional logic in SQL statements. It is similar to switch case statement, where each case is being checked. On the left side we can see age groups example, where we add new column to our client table, and based on age of client we insert age group to each client. So for client with age 18 we add age group from 18 to 35, and so does for other clients. And let's check our client table, and we got each age group for each client. Let's consider other example where we make discount based on the quantity of orders. For example, if the orders are more than 10, we make 20% discount, and in other case, we make 10% discount for the price. And I already inserted the query, and we will have our orders with discounts. Constraints are used to ensure that the values in a column meet a certain condition. So we cannot insert values in table that do not meet the condition. For example, here we have two constraints for age and gender. And let's also see our all constraints for table client. It's client primary key, client email, and client age. And let's also add constraint for gender. And we can insert only male or female values. And here we can see our updated new constraint for gender. And let's insert client with NA gender. And here we got our error, client violates check constraint gender. And also if we amend age, the constraint will also be violated because we have age constraint. The trigger is a function that is automatically executed in response to certain events or actions. For example, this trigger function checkPrice will control orders insertion and will not allow orders with zero price. In other case, it will throw an exception, and if we insert order with zero price, we will receive an exception. Function checkPrice, price cannot be zero. So this is the end, and thank you for your attention.